Williams.
And I'm Billy Thomas.
And welcome to another edition of From the Woods Today.
We've got two really interesting topics today. It's just different that we've talked about flooding in the past and, all the devastating floods that have happened in Eastern Kentucky. And it just seems to be getting more and more and more. And then, another topic that we have is like animal signs. And how do you know? I've always wondered that, you see something in the woods and you're like, I wonder what kind of animal that is. So, we've got both topics. So both very interesting today.
No doubt. Greetings, everyone. Yeah, we're going to have a great show today. Really excited about it. We've got a guest that it's been a couple years since we've had him on, but we're going to have Dr. Chris Barton on with us. He's a forest hydrologist here at our department. Also runs Green Forest Works, kind of does a lot of mine reclamation. But he's going to be talking about some of the flash flooding issues and some of the things that we deal with. Certainly our topography and other things play into that, but there's a lot more going on. So we really look forward to hearing from Dr. Barton. I know, Renee, when we're down at Robinson Forest, it's not uncommon to hear about flooding and, and
Right.
people having to get out of the camp and stuff like that. So this is not just, a rare occurrence, right? It happens all the time. And as you said, we're having more and more frequent, about 500,000 year events are happening very frequently. So yeah, we really look forward to hearing from Dr. Barton. And then as you mentioned, we also have Miss Frannie Preston with us. Love having Frannie on today. She's going to be talking about wildlife signs, So what, when you see some of those tracks or other things out there, what do we do with that knowledge? So she's going to help us go through that. So really excited to have her on. But we're glad to have you all with us, right? Without you all, the show is just Renee and I talking to each other. So, but we're glad to have you all with us. Really are. But if you have questions for either one of our presenters, please use the chat function and we'll get to you there. If you are on YouTube or you're a podcast listener, thank you very much. We appreciate that. But we can interact with you via email. If you can email us at forestry.extension@uky.edu, we can respond to you that way. But Renee, glad to be with you today on this day before it starts getting a little bit cooler.
Oh, please, a little cooler. Yes, exactly. We're going to be wearing sweatshirts and it's 80 degrees outside because it's been so hot. But let's go ahead and get started. So, Dr. Barton, if you want to turn your camera on. Hi, welcome to the show. We appreciate you being on.
Glad to be here.
Yeah, I've talked to you about this for a little bit, trying to see, it's like, why is all of this happening all of a sudden? It just seems like it keeps going and we get these bigger floods. And I even noticed here in Lexington, we get downpours. I mean, I think it was Sunday. It's like someone just flipped a switch and it just started pouring, and then you flipped a switch and it was off. It was just very unique weather.
Yeah, and it seems to be more of the norm as we move forward. And so I think what I'm going to talk about today is actually very timely because these catastrophic flooding events seem to be, becoming more frequent and affecting more of us in our communities. So I was hoping today to talk a little bit about, what the issue is and maybe provide some solutions, some potential solutions to the problem.
Nice. Okay. Looking forward to it.
Yes, glad to have you with us today, for sure.
Well, again, I'm happy to be here today to talk a little bit about, what's been happening with all of these catastrophic floods that seem to be more commonplace every year and every month. In Appalachia, as Billy mentioned, we deal with flooding quite frequently. And one of the things that we have observed is that over the last 2 decades, extreme rainfall has increased by nearly 30%. And these billion-dollar disasters associated with these flooding has more than doubled over the past couple of decades. And we do know that because of its topography and because of the number of streams within central Appalachia, and this includes a lot of eastern Kentucky and West Virginia, it's really one of the most flash flood prone regions in the country. So images like these, unfortunately, are not that uncommon in this region. So 3 years ago, we had about a 12 to 16 inch rain event in 24 hours in parts of eastern Kentucky, mainly around the city of Hazard, along Troublesome Creek watershed. This was a devastating flood that we're still dealing with to this day. There was 45 deaths associated with it, and it displaced over 10,000 homes that were destroyed in the flooding. So not only the 10,000 homes, but the occupants in there is a number, quite larger than that. So as I mentioned, at Robinson Forest, which is right there in Breathitt County, which is in the heart of this area that got about 10 inches or greater, we're still dealing with the impacts from that flood 3 years later and still sort of rebuilding. And a lot of my hydrologic equipment, things that were in the stream to monitor the stream, was destroyed, and we're rebuilding it. But this rainfall event is what happened that night was kind of similar to some other rainfall events that had been happening more recently. And what we saw is that I think it's been referred to as an atmospheric river, but a really hot and moist weather pattern that came through the area, lifted and cooled, and all of that water just fell down. Last year, Hurricane Helene similarly came up from a hurricane that originated in the Gulf of Mexico, went up through the southeastern United States, got into the Appalachian Mountains, and released about 30 inches of water, rainfall, in one day. There was 252 deaths associated with this event, and nearly $100 billion in damage. In fact, about $50 billion in damage just to Western North Carolina. I was in that area last week, and they're still building a lot of bridges and doing a lot of repair from this storm. So catastrophic. 2025 in Kentucky, we've already had 2 flooding events, one in February and another one in April, both of which caused loss of life, loss of property. West Virginia similarly had also had flooding in February, and as recently in June up in Wheeling, West Virginia. Again, loss of life, catastrophic to infrastructure. And then most recently, last month, we had the Central Texas flood in the Guadalupe River, where we had over 10 inches of rainfall within a 24-hour period. Over 100 people were killed, including a lot of young girls that were at a camp, the Camp Mystic, that were swept away in the flood. So, as Billy mentioned at the beginning of this, what's up with all of these recent 100, 500, and even 1,000-year storm events? Well, what's happening is the planet is getting hotter. And this was a recent study that was published in 2023 where they looked at global temperature rise in both the land, the ocean, the southern Midlands, the northern Midlands, tropic, Arctic. And what they found in all of these locations was that the temperature since 1980 has risen about 2 degrees centigrade. And what happens when you raise the temperature, your likelihood for evaporation and water vapor getting into the atmosphere increases. So we see a very similar and concurrent rise in water vapor as we see temperatures, both in the water and land temperatures, going up. So the cause of this is greenhouse gas emissions, or carbon dioxide, methane, things of that nature, where they get into that are released during fossil fuel burning. They accumulate in the atmosphere and they trap heat. And one of the things that happens when you trap heat, the hotter the atmosphere is, the more water vapor it can actually hold. So we have higher temperatures, we got higher evaporation, higher evapotranspiration, so we have more water vapor in the atmosphere. And actually the water vapor becomes a greenhouse gas as well, and that helps warm it up even more and allows it to hold even more water. So you have this sort of, feed loop of, increased carbon dioxide heating up the atmosphere. That increases the water vapor, and the water vapor actually heats it up even more. So where we're seeing this in the southeastern United States and other places is we are heating up essentially the Gulf of Mexico because of this hotter atmosphere. We get a lot more evaporation from the ocean, but we're also getting higher than normal temperatures in the Southwest United States. So more evaporation of the land mass, more evapotranspiration as this hot air accumulates. And so these warm, very moist fronts move northward where they often cool and it drops all of that water out very quickly. So that's one of the things that's happening is these atmospheres are becoming saturated with water. And then when they hit a cool, air mass, either by moving north or by lifting up over a mountain range, all that water comes out. And that's why we're seeing these sort of catastrophic, 500, 1,000 year rain events and flooding events. So when we look at are things really warming up here in the United States, we look at these decadal precipitation and temperature changes. And what we find is that, in fact, since the 1980s, we've seen about a 10% increase in Kentucky anyway, in the amount of annual precipitation that we're observing. We also see a concurrent about 1 to 2 degree increase in temperature in that same time period. So when we look at our entire record of Kentucky weather from 1985 to present, we see that 5 of the wettest years in Kentucky have occurred since 2010. So in the last, 15 years, we've had 5 of the wettest years on record. So 2011 is currently the wettest year on record, but right now we are on track to exceed that this year if the conditions continue the way that we have been seeing. So we're definitely getting wetter, we're definitely getting hotter. After the 2022 flood in Eastern Kentucky, a lot of the media was calling it a 1,000-year flood event. And I thought, well, this would be a good opportunity to teach, students in my class. I teach a watershed management class, how they come up with that number of a 1,000-year flood. And there's a statistical approach for doing that called a frequency analysis, where you basically determine the probability of a storm like that happening based upon the record of storms that you have. So I had my class actually map out using maximum 24-hour precipitations from rain weather data that we have at Robinson Forest. And they calculated that to actually be a 875-year event. So pretty close to that 1,000-year event that everybody was talking about. But the problem with this analysis is that once we have had that particular event, it becomes part of the record. And since 2022, we've had 3 more floods at Robinson Forest. So if we reran the analysis using data up to present, that 2022 event or another event that had 10 to 12 inches of rain in 24 hours would actually be now considered a 50-year event. So it's obvious from this data that, as these events are becoming more common, they're no longer 500 and 1,000-year events. They might be 25 or 50-year events. So it's something that we need to think about going forward. So who or what is responsible for all of these, increased frequency of flooding? Well, a lot of people point at climate change. And again, if we have more CO2 in the atmosphere and the atmosphere is heating up, then that certainly makes sense. Some people think that it might actually be an effect of El Nino or La Nina, where weather changes happen with certain natural variation. And so maybe it's just a little period we're going through. It's a possibility. A lot of people, point their fingers at the energy companies for burning all of these fossil fuels. Other folks are looking at the surface mining for creating, the coal that we do burn, but also for deforesting landscapes as part of the mining process. You can also point your fingers at consumers of fossil fuel, like me, who drives a car and eats beef and things like that. All of these are emitters of greenhouse gases. And I could go on and on and on. So it's, there's a lot of things that we can point at what's causing this to happen. But the bigger question is, what can we do to solve these problems? And one of the things that we can do is limit the amount of CO2 emissions from cars and power plants and things like that. Or we can look into expanding carbon sequestration methods. And some of these sequestration methods are capturing CO2 from power plants and turning them into like cement type products, or direct capture of carbon dioxide from the atmosphere, and deep geologic sequestration by pumping that stuff down into deep aquifers where it becomes a liquid and can stay there permanently. There are some permits that have been approved, and they've started actually doing this in Wyoming. And it looks like it may become a more common practice going forward. Another method that we can use to capture atmospheric CO2 is to plant more trees or do reforestation, as the trees will uptake CO2 and store them in their biomass. So I like this idea of planting trees as a method for capturing CO2 and sequestering it into the biomass. And this has actually two benefits if we think about it, from both climate change and the flooding issue. This is a picture of the Troublesome Creek watershed in parts of Breathitt and Knott County, Kentucky. And one of the things that we can use this to sort of highlight this issue is that this particular watershed, which was devastated by the flooding, probably more than any other watershed of 2022, has about a third of its landscape has been either actively mined or formerly mined for coal. And one of the things that happens when you do that is you remove the trees, so there's a loss of the forest. And oftentimes they're reclaimed into non-forest type of landscapes, so grasslands that tend to be compacted. So you lose the forest, and you're losing that the capacity of the forest to intercept rainwater and utilize rainwater. So that potentially can become more runoff. Also, the mining compacts the land after they reclaim it, which can also lead to increased runoff. So you can look at these mine sites as one, they're deforesting the area, but two, they're also potentially accelerating the flooding problem because the trees aren't there to help mitigate the impacts of the flooding. So we do know through research, and when I was on in 2022, I talked about some of the research that we're doing to get these mine sites reforested. And this is a typical valley fill in eastern Kentucky. After it's been reclaimed, it's reclaimed as a grassland. There's very few trees growing on it. We went in and did a project and planted about 50,000 trees in this watershed. We did that in 2009. Here's the same site 10 years later. Here it is 15 years later. So we have the capacity to bring back that forest to these landscapes. And one of the things we know from our long-term monitoring at Robinson Forest is that about 55% of our annual precipitation that goes into the forest goes right back out to the atmosphere via evapotranspiration. So those trees provide a place for water to be intercepted in the canopy and evaporate off the leaves. But it also provides, the ability for the trees to uptake, especially during the growing season, some of that water from the soil and transpire it back. So putting forest back into this landscape is a really good method for potentially helping mitigate some of the flooding, but also helping by putting that forest back to mitigate some of the CO2 issues that are in the atmosphere. So I do have a nonprofit organization called Green Forest Work, and we've been working to put forest back on these mine landscapes. Since 2009, we've planted about 8 million trees in Appalachia and in parts of Australia where mining occurs. This is part of a bigger effort, the 1t.org, to plant 1 trillion trees across the globe over the next 10 years, and also part of the United Nations Decade on Ecosystem Restoration. So this is a big, program to potentially reforest the planet and help with sequestering carbon, mitigating climate change. But it's not enough. So what are other things that we could do to potentially help mitigate the amount of carbon dioxide in the atmosphere and regulate these greenhouse gases? Well, what about a regulatory approach? We could limit CO2 emissions as part of the Clean Air Act. But anytime that this has been basically brought up, it gets a lot of skepticism, and it really hasn't moved very far as becoming a regulatory, compliant emission. But we do have data from earlier where we looked at the use of the Clean Air Act to reduce acid rain in the United States. And it's been a very successful program. This map here is specifically for Robinson Forest in eastern Kentucky. And what you see in the top part is some data from 1985, where we have sulfate emissions around 50 kilograms per hectare in this red or orange. And as far as nitrate, you have about 30 kilograms per hectare, showing green here. But we looked at 2012, and we're basically down to zero sulfate emissions in eastern Kentucky, and almost no nitrate emissions either. So over that period, from when the Clean Air Act was initiated to just a few decades later, we've basically eliminated the problems with sulfur dioxide and nitrous oxide in the atmosphere. This is one of the National Atmospheric Deposition Program rain gauges in Mackville, Kentucky. And we can see from 1980 through about 2012, we have a 70% reduction in the amount of sulfate in the rainwater. And remarkably, at Robinson Forest, we've actually seen about a 50% reduction in the amount of sulfate in stream water. So not only are we keeping the sulfur dioxide out of the atmosphere, we have less amounts of it in the rainwater, and we're seeing that actually come through the soil and into our stream water. So a whole sort of ecosystem level reduction of these gases, all due to the Clean Air Act. So how did it work? Well, we shifted to low sulfur coal. That helped take some of the sulfur dioxide out of the atmosphere. A whole bunch of new technologies were developed. We had scrubbers and catalytic converters and renewable energy sources that reduced the amount of fossil fuels are actually being burned, or captured it and did something with it. And then changes in behaviors on what we consider to be suitable for emissions, and low energy demand appliances and things like that. All of this helped to make the Clean Air Act work for acid rain. So a lot of innovation and many, many other things went into making this one of the most successful environmental policy acts that we know of. But we have some breaking news. As of yesterday, believe it or not, Lee Zeldin, the administrator for the Environmental Protection Agency, is planning and announced that he was going to rescind the 2009 declaration of the endangerment finding, which concluded that the planet warming greenhouse gases pose a threat to public health. So by doing so, it would be the largest deregulatory action in the history of America, as reported by the New York Times yesterday. So rescinding the endangerment finding would allow basically, automotive manufacturers and energy producers to go unchecked on the amount of carbon dioxide emissions that they will have. It hasn't been passed yet, but it's something certainly to think about. And I guess what I'm trying to pose is that the fact that the Clean Air Act worked for acid rain, I don't know why it couldn't work for CO2 emissions. If we did limit those emissions, we have the ability to improve our air quality, to mitigate climate change, to spark more technological advances to deal specifically with CO2 emissions, create new jobs that will basically be geared towards solving CO2 emission issues, and flood mitigation. If we can reduce the amount of greenhouse gases that are emitted to the atmosphere, that potentially could cool down the atmosphere, not allow it to hold as much water. And we could see the mitigation of some of these catastrophic floods that have been in the news so frequently recently. And that's all I have for now. Thank you.
Wow. Thank you so much for that. You know, that Guide Cove photo that you showed, that was amazing, you know, how that forest just came right back. And now that would not have happened had you not planted the trees. Is that correct? Or would it have happened over time eventually?
Well, probably it could have happened over many decades, if
Right.
not centuries, but probably the seedlings that we planted out there were native to that area. And what we see with these sites, that if you don't plant them, they actually get invaded by a lot of non-native invasive species. And so that becomes another problem that we have to deal with long term. And it has lots of ramifications on the whole ecosystem services of those areas. You know, the wildlife habitat isn't going to behave similar in a native forest versus invasive species forest. So something to think about. But yeah, so I mean, clearly we can grow trees, and we know that the trees will sequester carbon and remove carbon dioxide from the atmosphere. So that's one easy solution. But we got to come up with a lot of other solutions to actually. There you go. To to solve this issue.
Yeah.
We did have a question. Someone wanted to know if there were any evidence of cloud seeding in Kentucky.
Not that I know of. It comes up a lot, and it's something that people have talked about, but I've not heard of it happening in Kentucky.
Yeah, Dr. Barton, thank you so much. Really do appreciate you taking time and drawing our attention to such an important issue as well. So, yeah, lots to think about for folks and maybe take some action on as well. So, yeah.
Definitely. Yeah. Thank you for being on. We appreciate it.
Yes, indeed. And thanks for the great work you do. Really, Green Forest
Mm.
Works, and you all have reclaimed so much mine land here in Appalachia, and you're really an amazing organization. So, yeah, congratulations to you and the whole team that works on that. I know there's a lot of people involved with it, but yeah, you should be very proud of that wonderful effort.
Good. Definitely.
Thank you.
Awesome, good
Right.
stuff.
Awesome. Yeah, good stuff. So
Yeah.
now we have another guest coming on, and Frannie, if you'd like to turn your camera on. You know, when we talked about this originally, I was like, when you see an animal, you don't know sometimes you don't know what you're looking at exactly. Sometimes you may be like, I see a paw print, but I don't know what that is, and it's just kind of interesting. There's a whole lot of different things that you might not think of that could be a sign of what certain animals are.
Wow.
Yeah, and there's a lot of, Dr. Barton just kind of talked about really big things that can happen in the forest that we have to look out for, but we're going to kind of shrink it down to really small things. So like you said, there's a bunch of different animals that are living in our forest, and we're just going to kind of talk about a few different ways that you can tell what's there without actually seeing the animal.
Awesome.
Looking
Glad
forward
to have
to
you, Frannie, for sure.
All right, so again, my name is Frannie Preston, and I'm the Forestry Works of Kentucky coordinator. We're talking about animal signs. So why do we even want to use animal signs? And I kind of just alluded to it, but a lot of the times animals in our forest in Kentucky are out at night, especially right now when it's really, really hot. And we're typically not out at night. We're typically asleep in our homes. Number two is animals are really good at camouflaging themselves. I've got some cute little northern water snakes right here, and it might have taken you a minute to find them in the leaf pile. They're really good at camouflaging themselves because they don't want to be seen by their predators or their prey. And we have some animals that are really common, like bobcats, that although there are quite a few of them here, especially in our forest, we don't see them very often because they're super sneaky. So because animals are nocturnal, they're good at hiding themselves, and a lot of times they're really sneaky, we need to figure out different ways that we can look for them without seeing the actual animal. One of those ways that you're probably pretty familiar with is animal tracks. And tracks is just another word for footprints. So when you're looking at animal tracks, let's say you're hiking through the woods and you come across some animal tracks and you want to know what kind of animal it is, first of all, you want to find as many tracks as you can, because unless it's a really homogeneous substrate like snow or something like that, a lot of times the tracks are going to look kind of different from footprint to footprint. And you can even imagine yourself, like walking through the mud or something, and maybe you're running at one point and your feet are going in deeper, or you're walking slowly, or you're going in different directions, and there's maybe sandy areas or muddy areas or rocky areas, and the footprints are going to look a little bit different. So when you come across some tracks, just try and find as many as you can, because it'll help you figure out what animal exactly you're looking at. And we're just going to kind of go over some overall what to look for when you're going through a track field guide, and I'll show a few of those at the end. But when you come across the track, the first thing you want to do, and you're probably going to do it automatically, is look how big it is, and then look at the shape of it. Is it long and skinny? Is it short? Do you think it's a big animal? Do you think it's a small animal, a medium-sized animal? You're going to want to look where it's at too. Is it next to water? Is it far away from water? Is it under a tree? Is it in a field? Getting to more specifics, you want to look at the number of toes if it is a mammal that's not hooved. So not deer, because you can typically tell deer or elk tracks pretty easily in Kentucky. But if we're talking about non-hooved mammals, you want to look at the number of toes first. And again, you want to look at as many tracks as you can, because maybe not all of the toes sunk in for one track and it might mess you up a little bit. So look at as many tracks as you can. But overall, some animals that have 4 toes in their tracks are bobcats, rabbits, and coyotes. So here's a bobcat and a coyote track that you can look at right there. Now, animals that typically have 5 toes in both their front and their back feet are possums, rodents, weasels, skunks, and raccoons. So if you see one and you're like, dang, that looks like a human hand, it has 5, you can kind of assume that it's going to be one of these animals. Next up, you want to look for claws, and this one is really tricky and it can actually throw you off a little bit. So most of the time, feline animals like bobcats are not going to show claw marks in their track prints. And canine animals like foxes and coyotes and wolves and dogs, their claws don't retract, and so they're pretty much always going to show claws. However, sometimes the feline animals like a bobcat, it might be running and sinking its feet really deep and its claws might come out a little bit, and so you might see some claw marks there as well. So just count the toes and then use a handy dandy field guide to help you look for more specific markings to figure out what you're looking for. But in general, most of the time, feline animals do not show claw marks with their tracks, and canine animals do. Another interesting way, if you see a bunch of tracks at once, that to kind of help figure out what animal it is to look at its gait. And that just means, how does it walk? How does it move? And so there's some different types of gaits that animals typically have. And I've got a few shown here. So bears have what's called a pace. And I kind of like to imagine this as how a lizard moves too, kind of moves at once. And just imagine how a bear walks, how it's going to leave tracks. And then deer, they leave what's called a diagonal gait. And then things like minks and weasels, they bound. And so you can think their front and their hind feet come up to their front feet. And so their tracks might all be kind of mushed together. And then animals like squirrels and chipmunks have what's called a gallop. And so their hind feet are going to be kind of close together. And then their front feet are going to be a little bit further apart. And you can see it's like they're galloping. Okay, so those are tracks. And again, I'll show you some field guides at the end. I just wanted to kind of go over some general rules. But then we've got scat, and this is one of my favorite animal signs to look for, because we'll talk about all the different things that scat can show you other than just what animal it is. And scat is just a fancy word for animal poop. So if we're looking at, we find some scat in the woods, and it is scat of a carnivore or an omnivore mammal, it's typically going to maybe have some fur or vegetation or even tiny little bones in it to show what it's been eating. And carnivore mammals, since a lot of times they're the bigger animals, they're the predators, they want to leave their poop in conspicuous areas to say, this is my territory, don't come in. And so if you find some poop in a really conspicuous area, maybe out in a field versus kind of hidden, it is probably a carnivore mammal marking their territory. They don't care where they go. They want to show that they're there. And it's typically longer and skinnier. So here is an example of a carnivore/omnivore mammal poop, and this is from a coyote. And you can see just the shape of it, you kind of know that it's a carnivore mammal. And this coyote in particular had been eating a bunch of grasshoppers. So you can see a bunch of grasshopper wings if you look really close, which is pretty cool. And then bobcat scat is typically pretty distinct as well. It's segmented, if you can see right there. So it's kind of, it's in one long strand still, but it's segmented. And you can see right here that it's got some fur, maybe some other pieces of vegetation that it might have eaten for digestion, but you can tell that it is a predator animal. And this was probably left in a conspicuous location. Now, if we're going more towards herbivore mammals, they're typically in patties. You can think of like a cow patty, or in pellets like a deer or a rabbit. Now, these might vary per the animal's health and diet, but that's typically what they are. And herbivore mammals, a lot of the time you can tell what they've been eating. So you might find grass or leaves or tree bark, berries, hard mass like maybe pieces of acorn or other nuts, and seeds a lot of the time too. So you will find those in herbivore mammal scat. Now, with birds and reptiles, because they evolved pretty much from the same thing, they have very similar poop. And so a lot of times as well, you can tell what they've been eating. We've all had birds poop on our windshield and we can see little berries or seeds in it, but you can do the same thing if you find snake poop or turtle poop. You might find that it's been eating insects. You might find tiny bones in it. You might find fur in it as well. And then here's one we're sometimes all too familiar with, especially getting it on the bottom of your shoe when you're trying to go fishing, Canada goose poop. So you can see, even if in this one piece, that it's got a bunch of grass in it, so you can tell what the goose has been eating. Now, fur and feathers is another great way to tell what animal has been around. And sometimes you might just stumble across it. A lot of times that's what happens, but I'll show you how people who are researching animals can kind of target an area to have fur and feathers. And here is a feather of a great horned owl. Now, big raptors, a lot of times they have the easier feathers to kind of determine what they are. It's really tricky with little small birds that are all brown. But one thing I do want to say, if you do find a feather in the woods, just take a picture of it and leave it there. It is illegal to collect any migratory bird feather. So any bird that's not a game species like a turkey, it is highly illegal to pick it up. So while they're cool to look at, they're cool to document. The same with collecting fur. There could be some permissions needed. So just take a picture of it and leave it there. You'll know what animals are in your woods otherwise. Another thing you can look for animals, and these are always fun to stumble across, are homes. So things like nests, bird nests. This is a squirrel nest, also called a dray. There's your fun fact for you for the day. A beaver lodge. This is always a fun one to come across. So beaver lodges, beaver dams. You can tell that an animal is there because it's living there. Or a lot of times you'll see holes in your trees. Maybe a squirrel or an owl is living there. Now, another really cool one is to look for feeding signs. So this is just signs that an animal has been eating there. And some really fun ones that are my favorite to look for are what kind of woodpeckers are in the woods right now. So different woodpeckers and other birds, they have specific foraging patterns that will leave specific signs in the trees. And I'll show you a couple of those. And so if you want to get into learning what woodpeckers are in your woods, some common ones in Kentucky that leave really distinct signs are the pileated woodpecker. That's the really, really big one that looks like Woody Woodpecker. And you know when they're there if you don't hear them when you're out in the woods, because you'll see that the holes that they leave. And so pileated woodpeckers, because they're really big, they leave really big marks behind. So you can see the holes in the tree where they've been trying to find some insects. And another really cool one is the yellow-bellied sapsucker. And so this is a smaller woodpecker, but what they do is they will actually leave a ring of holes around the tree. And so they'll do it on a bunch of different trees. I see it often on cedar trees. As their name implies, they're called sapsuckers. And so maybe some trees that have more sap, so maple trees, cedar trees, and you look and they've got just a ring maybe all around the tree of a straight line of holes. So you can know that a yellow-bellied sapsucker is in your woods. Another really common one, especially for animals that we maybe want to manage for a little bit more, if we're maybe have too many or not enough deer and rabbits on our property, we want to look for these signs. And so these can be really tricky to look for, but if you're spending a lot of times in your woods, you'll find them. So it's called just how they're browsing, and they leave signs with that. So rabbits, because they've got really sharp teeth, if you find rabbit browse, typically it's like a sapling or a twig or something that's been cut clean off. So it's a really sharp edge, and you can look for their scat as well. Now, when a deer browses, of course, it might be higher up, but maybe not. The leaves or the top of the sapling is going to be kind of more jagged versus what a rabbit's looked like. And you can look for their droppings as well. They're going to be bigger. They're going to be more oval shaped versus a round rabbits. You all probably know what this one is, but you can also tell if beavers are around based off of how many trees have been bitten in a circle. So that's a fun feeding sign to look for as well if you live near a waterway. All right, and then some feeding signs for carnivores. So a lot of the time you can tell if there's a carcass still left there of a rabbit or something else that a carnivore, another animal has been eating. You can sometimes tell what animal has left it there. For one, if it's a really big animal, maybe a deer has been killed in your woods, and it's been dragged a far away. This is not as relevant in Kentucky, but it might be a bear or a mountain lion, an animal that's big enough to drag it. So you can watch for the drag mark and how far away it is. But if it's a smaller animal, which you're typically going to see more, sometimes you can tell by the scrape marks and the track marks next to the animal, the prey animal, or how it's been bitten, kind of its teeth mark. It's almost like Criminal Minds for wildlife. Now you can also tell if a raptor was the one that killed that animal, if its eyes and tongue are gone first. Little creepy, but kind of cool. You can tell what animal killed that animal or what animal has been eating that animal as well. And then you know those are around, those are in your woods. All right, so of course, it's really fun. We can all go out to our woods or where we're hiking and look for animal signs for fun. It helps us learn more about what's around us, especially since a lot of the times, as I said, the animals are going to be hidden or asleep. But scientists will also use animal signs for research for the same reasons. So we can, again, we're not always going to see or hear the animal in the woods, but we want to know that they're there. And we can use homes, fur and feathers, scat, feeding signs to say that an animal is present or not present in an area. And this can be used to measure how many of that certain species there are, or what the biodiversity is like in that ecosystem. And biodiversity is how many different living things. So we can use animal signs as researchers to determine these things. Like I mentioned with the carnivore scat, is that they'll leave it in really conspicuous areas. So you can do even like DNA testing and see, okay, this coyote is leaving its scat in all these different areas. This is its territory. This bear is leaving scat in all these areas. This is its territory, things like that. And you can also measure the health and diet of the animals in the area based on their scat. So again, a lot of times you can either see or use a microscope to see what all the animal has been eating. Has it been eating fish, insects, rodents, leaves? And you can use SCAT to determine the animal's health in the area too. Obviously, they can test for different diseases, but also if a bird has really yellow poop, it might signify liver damage or something like that. And so even the color of the SCAT can be used to determine the health of the animals in the woods. So when research is being conducted using animal signs, it can be considered a survey. And this can be maybe a certain area set that they want to look for a specific animal or look to see how many different birds are in the area or something like that. And they will determine what areas to look at. And they might come across signs or they might not. So it could be incidental, and they might come across hair snagged on a branch. Or they might not. So that would be kind of considered more incidental, but still part of an experiment. Or there are ways to target these animals to see if they are in the area. And I'll show a couple examples of those. So again, this is incidental. They've come across tracks. They want to document them. Some different ways to document tracks are either making a cast of it or just taking pictures as well. Now, a way to target to see what animals are in that area and make them leave tracks in a certain area, it's called a track plate. And there's a few different ways to make this. But this person rubbed like charcoal on this metal plate. And then the animal tracks were left on it. They probably marked it with some scent or food to get the animal to come to that area just to kind of see what's there. So this is called a track plate, and that's one way to do research to see what animals are in the area. One of my favorite ones, especially with bears, it's called a hair snare, which is a fun rhyme too, a bear hair snare. And what they will do is if they want to see maybe how many bears are in an area, or another animal that really likes to rub up against things, they will build these snares, and they might be different things. They might have little metal pieces on a piece of wood. It might be a barbed wire fence. And then they can use these to attract bears to the area with scent or something like that. Or they might just come out of curiosity because there's a wooden structure in the middle of the field now. And they'll rub up against it, and they can collect that bear's hair to collect its DNA and do different types of research. Now, each one of us, again, we can do this for fun. We can go look for tracks and scat and hair and homes for fun, but you can also contribute to research as a citizen scientist with things like iNaturalist. So iNaturalist even has projects specifically made for scouting out different scat in the area, and you can upload any picture of animal scat you can find, and you can either ID it yourself or someone will help ID it for you. That's what's really cool about iNaturalist. So you can go on there and help contribute to research, and people will actually use that who are researching different species to look, yes, these animals were confirmed in this area based off of their tracks or based off of their poop as well. All right, so a lot of this information I got from a wildlife techniques manual. And this is more of a textbook version with a bunch of information about animal signs. But if you're looking for just learning a little bit more about tracks and scat, you want to head out to your woods once it cools down a little bit and start looking for stuff. There's some different field guides you can find. Some of them are more broad with North America, or you can look for like a Midwest one or a Southeast one that has animals more specific to Kentucky. Kentucky Fish and Wildlife has a really cool pocket guide that you can see in the right-hand corner, and it's kind of just got a small thing. It's got a ruler on it so you can measure it with some different tracks that you can find in Kentucky. And all of this research will lead to management. So why do we care about finding it other than just for fun to know what animals are in the area? Well, if there are rare species that we're looking for, we want to be able to know that they're there without seeing them sometimes. That way we can manage an area for them better. Or if there's too many of one animal, maybe a nuisance species, and we want to know how many are in that area, we can use these signs as well. So I appreciate you all learning today about different animal signs. And as soon as it gets cooler, you're going to have to head out in your woods and look for some.
Yay, that was awesome. Thank you so much. Great. I didn't realize all the different ways that you could possibly track an animal and learn about them.
And the more you do it, the better you'll get at it.
No doubt. That's awesome. And it seemed to go so well with Dr. Barton's
Yeah.
presentation. When it's really wet, you can see those tracks a lot better, I
Mhm.
guess. But yeah.
Didn't think about that. Right.
Yeah.
You're absolutely right, Billy.
Oh, no, we really appreciate that, Franny. And like you said, we hope people can use this knowledge to kind of, you know, uh, manipulate the habitat for certain species if that's what they're looking for, or make it healthier overall, or whatever they need to do to try to help the wildlife in their area. So, yeah,
Just find out what they have in the first place.
Mhm.
it's always the thing. You got to know what you're dealing with, right? Whether you're trying
Mhm.
to treat an invasive plant or try to manage for a species, you got to know what you're dealing with. So, no, good stuff, Franny. As always, really appreciate the work you do for us here.
Thanks for
Yes.
having me on.
Thank you. Appreciate it.
Good stuff.
All
Excellent.
right. Awesome. It was a really interesting show today. I liked both topics, and both, didn't plan it where they would kind of, coincide, but it worked out real
Yeah,
well.
no doubt. Appreciate Dr. Barton coming on and talking to us about what's going on with the flash flooding issues.
Mhm.
It's more than topography, right? There's
Yeah.
some other things playing. Certainly do appreciate him, as well as Frannie Preston talking about how we can kind of identify wildlife by the signs that they leave for us. So yeah, really great presentation from both our guests. But folks, it's for you all.
Mhm.
So please help us spread the word about this program to others that could benefit from it. We really appreciate that. We want to try to help our landowners out there, or those who are trying to support our landowners in Kentucky, be good stewards of their natural resources. So please help us spread the word. But thank you all for being with us today.
Definitely. And if you have any topics that you would like for us to cover, you can email us at forestry.extension@uky.edu. Or if you go to fromthewoodstoday.com, there's a little survey there. You might find something out in your woods that you take a picture of, and we may send it to Franny and see if she can figure out what it is. But
Yeah,
yeah, but we've got plenty of people here in the Department of Forestry who can kind of tell you what that may be, or they could get you to someone who will know.
no doubt about it. So yeah, let us know what you're seeing. Like we said before, if you see something out in your woods, it's maybe new or different. It may be something we all need to be aware of. So
Mhm.
you can help us all out by alerting us to some early arrivals that we may not want in our areas. But no,
Definitely.
good stuff. While they're there at fromthewoodstoday.com, they can catch up on all the back
Mhm.
episodes, 250 plus episodes there. So
Yes, exactly.
a lot of great content on there, folks. Most of it is timeless for the most part. So just get in there and binge away if you want. So
All right. So we greatly appreciate you joining us, because without you, we wouldn't be doing this. So we will definitely see you all next week. You all take care.
thanks,
Bye.
everyone. All right, bye bye.
From the woods today. From the woods today.